Hello, this video is going to be about finding an equation that passes through 2 points. And that's the 19 through 27 off that page 147 workbook. All right, and so if we're looking here at 19, this is one that we had done in class, but we're given 2 coordinate points, x1, y1, x2, y2. This is talking about my x and y coordinate for my first coordinate point, which is what this 1 denotes, and my second coordinate, which is what this 2 denotes. Right? And what we used to find our slope on this was, we see it boxed here, is this formula right here, that y2 minus y1 divided by x2 minus x1. It's telling me my change in rise over my change in run. So this is me selecting the different values that come from our equation points. I'm identifying, hey, what is my change from one y to the other point? It was -1. What was my change from one x coordinate to my other one? It was -3. So we simplified this because since they're both negative, we know that that's really just a positive 1/3. Okay, so that tells us our slope. Now to find the y-intercept, this is where we have to take our slope, right? We choose one of our coordinate points, one that's preferably easier to work with, right? And cover this up like this. That's why we use our y equals mx plus b. We chose this second coordinate point because plugging in 0 is going to be a little easier to work with. All right, and we take our x coordinate, plug it in for our x. Take our y coordinate, plug it in for our y. And then once we get that set up, this is us just plugging in that y, plugging in that slope, plugging in that x to solve for b. All right, in this case, since we chose that 0, it worked out nicely for us because it tells our y-intercept right away was at a 4. All right, so in this, there's the final equation, and that comes from taking this slope, taking this y-intercept, and composing it into an equation for us. All right, so I'm going to take us through the same process here. This one's number 20, and this is getting into when we have fraction y-intercepts. All right, and it's important that we know the mathematical concept behind this, because if we were to graph these 2 points and draw a line between the two, and we were trying to determine the equation from that, we wouldn't be able to precisely and 100% with confidence say where we are crossing the y-axis, because it's going to be a fraction here. All right, so we go through that same process to find our slope. This is using the y2 minus y1 over x2 minus x1. All right, so you can pause it here if you need some more time to take a look at that. I just came from taking these values, plugging them into the formula. Now this is us going to find our b. All right, so once again, I choose one of my coordinate points. We chose 2 and 6. All right, a little easier numbers here to work with for us. Instead of -4, -2, we get to avoid some negatives. We plug in the 2 for my x, plug in the 6 for my y. That's what we see down here in the equation below. And we also plugged in that slope of 4 over 3. All right, so what's going to be happening for us now is we're going to need to address some fraction work. All right, and now originally, this 2 that we plugged in for the x was just a 2, but we made it a 2 over 1, so when I multiply my fractions straight across, right, 4 times 2 gives me this 8, 3 times 1 gives me this 3, okay? So we have right now that 6 is equal to an 8 divided by 3 plus a b. So what we're going to need to do here is finish off doing some fraction work to figure out how I can get b by itself. All right, so on this side, I'm going to need to subtract both sides by this -8 over 3, right? That's how we would get rid of it, is we would have to subtract it. So what I do from one side, I must also do from the other. All right. So over here, these will just cancel out here for us, right? Because any number subtracted itself is going to go away. So we'll be able to determine what my b is equal to. All right, but in order to do this, we need to do this 6 minus this 8 divided by 3, right? So what I'm going to do is I'm going to do some rearranging here. I'm going to give myself some space to take a look at this. And I'm going to do it here in this, I'm just going to draw up a box here for me, to where I'm going to do this actual 6 minus an 8 over 3. All right, now we know for fractions that we need the same common denominator in order to be successful when dealing with the numerators, right? So right now I can't do 6 minus 8 until I get the 6 over a common denominator of 3. All right, and any number just starts off with a denominator of 1, right? 6 divided by 1 is 6. Same thing. So now I'm trying to get it paired up with this denominator of 3. So what I know I'm going to need to have happen is my denominator needs to multiply by 3. But in order to keep this safe and fair, I'm not allowed to actually change a value. So I will also multiply the numerator by 3, because 3 divided by 3 is just a 1. Alright, so I'm going to multiply these straight across to give myself an 18 divided by 3. Right, 18 divided by 3 is still just the same 6 that we had, right? But now it's in the same pieces, our same denominator as our other fraction, so that I can successfully operate what was asked. Okay, so now it's 18 minus 8. Right, we don't worry about the denominator, it's just telling us the type of piece. 18 minus 8 gives me a 10. So my y-intercept is at a 10 divided by 3 here. Okay, so I'd be able to take this as my y-intercept. Right, we'd be able to take our slope, which was a 4 over 3 from right here, and write out that original equation. Right, so I can fill that same b information right here. Here's my slope. So we know that m here was equal to here to a 4 over 3. So we could take this information, these two things in conjunction with one another, and write out my final answer, which would be y is equal to my slope. So we have a 4 over 3x right, plus this 10 over 3. So we can see how if we were asked to graph this to find out the equation, we'd see that we aren't crossing over the y-axis at a whole number, and it would be hard to, with 100% confidence, say, hey, that's 10 over 3, right? Because when we're in between two grid lines on our graph, we can't be positive about what it is. Maybe it's 11 over 3. Maybe it's 10.2 over 3, something very, very close, right? But we don't know. That's why we need to have the mathematics so that we can always 100% for sure find our equation through 2 points, no matter how messy the slope or the y-intercept is. So this last one here is going to be number 22 here for us. Write an equation through these 2 points. Here's us finding our slope. So be careful, notice that this is x2 minus x1, so my x2 is 3, and to subtract a negative 7. So when I subtracted the negative 7, that's why it turned into addition. Subtracting a negative number is the same thing as adding. We had a negative 5 over 10 simplified to a negative 1/2. Right? So the coordinate point that we chose to use this time is 3, 0. Right? 0 is going to be easy to work with. Now, here's me plugging in 0 for y, 3 for x, my negative 1/2 for my slope, which came from right here, and we're solving for our b. So we multiply straight across to get that 0 is equal to a negative 3 over 2 plus b, right? Because 1 times 3 is 3, 2 times 1 is 1, so we got these numbers here with this negative sign along with it. Now the nice thing about choosing 0 is when I go to add 3 over 2 to both sides, it cancels out from this side, and 0 plus 3 over 2, I don't have to do any fraction work. It's just 3 over 2. So then we know that our b is 3 over 2. We know that our slope is a negative 1/2, so I can write out that final equation just like that.